Welcome everyone to the first afternoon session. For the first talk in this bracket, we're going to have Python, a Toy Language by Dave Beazley. This is a 45-minute session. We'll have 40 minutes of Dave and then 5 minutes for questions. So please, a warm welcome for Dave.
Yeah, right. All right, the first thing on this talk, you guys hear me okay? You got the sound okay? I am not Audrey Roy. You probably figured that out, okay? So Audrey, I think, is on a plane right now. Couldn't make the conference for this, and I didn't even know I was doing this talk until 2 days ago. So I'm wondering, what in the world is this going to be about? So Python, a toy language. Might be looking at that saying, this is going to be about Fibonacci numbers, toy problems, things like that. No, it's going to be about something much worse than Fibonacci numbers. It's going to be about kids, basically, okay? So just to be clear, there's not going to be a whole lot of heavy, hardcore technical content in this talk. So if you're looking for like meta classes or something like that, you're probably in the wrong place. I'm going to talk about Python, doing stuff with kids, and if you don't have kids, or if you do, you probably know it's a pretty amazing science project, if you think about it. You know, all the advanced biology and chemistry that goes on there, and there's elements of machine learning, which are kind of wild, you know, language and so forth. Probably the most amazing thing is that kids also have a very natural hacking instinct. This is mine. He already has a coffee and a pastry in front of the computer. He's ready to go. The other cool thing about kids is, as a parent, you get to build all sorts of cool stuff. We had in the keynote, we were sort of talking about, how do you inspire, kids to make things, to become makers and all this stuff. That's kids. I want to be making stuff. I mean, as a parent, you get to make all sorts of cool things like block towers and dog houses for like toy dogs and things. Okay, so get to do that. Maybe make a bird house for a real bird. Tons and tons of stuff that you get to build. And just as a hacker pro tip for all of you, who are thinking about becoming parents. I mean, I never really thought about this before I had kids, but kids are like the ultimate excuse to buy any tool, no matter how sophisticated, to solve any trivial problem. It's like changing a light bulb. Definitely need like an arc welder or something. Right? Okay, so you can drill presses and telescopes and oscilloscopes and soldering irons and all these like kid inappropriate things. Basically for yourself. Just don't tell your wife about how much it costs sometimes. Okay, so it is an excuse to buy all sorts of interesting, fun stuff, and the question that I'm sort of thinking about this, I have two kids. They're 3 and 4 years old. 2 boys, and I sort of think about this all the time. It's like, how do I get the kids to want to grow up and be some kind of like, pirate scientist, benevolent dictator or something? Actually, at one point, one of my kids told me, he's like, yeah, Daddy, I want to be a pirate scientist. And I was like, excellent. I don't know what that means exactly, but there's, and in space too. Okay, so there is this question, how do you do that? They're probably a little young to just give them a computer, although they do seem to pick up the iPad pretty fast, kind of scarily fast there. And so I have this sort of thought. It's like, well, maybe I could get them involved or do something to make toys, and maybe involve Python in some way. I mean, I'm a Python programmer, like programming. Could I learn how to make toys in Python? With kind of this premise, that Python and kids and building stuff, that's a good way to have fun, and it's also a really great way to avoid working on the book. Okay, now the book I'm talking about is that book. Okay, so the Python cookbook. Can I find some way to avoid working on that by doing stuff with Python and kids and stuff? So, and then there's this. I don't know how many of you saw this tweet though. This was maybe a week ago. Yeah, March 8th. What's your job? Programming, hobby, programming. What are you doing when you're not programming? Thinking about programming. I mean, I don't know how many of you are like that, but I'm kind of like that. I spend a lot of time thinking about programming, thinking about, could I put a regex in this? No matter how inappropriate it might be. So writing Python programs to make toys seemed kind of like a no-brainer. And there's also been this, kind of a movement going on right now with some of the maker stuff, 3D printers and hacker spaces and Arduinos and Raspberry Pis, stuff like that. It's kind of been on the back of my mind, actually, for a little while. It's like, it's kind of cool. Might be interesting to get involved with that. But honestly, I've actually never been that active in that community directly. I mean, it's as a parent, I mean, it's like tons of time. It's like I'm running a business and traveling. It's like I just don't have time to be like hanging out at the hacker space. Okay, so it's always been kind of like a little side thing. And so maybe about a year ago, actually after the PyCon conference last year. Sort of thinking about this. One issue too with some of this making stuff. This might be more of a personal thing. To me, I'm not like making stuff. I'm not so interested in the idea of just drawing a picture on the computer and just clicking print. It's like, okay, that's kind of cool and stuff, and it's like, I can see the appeal of 3D printing and so forth, but that's not really, for me personally, that's not what I want to be doing. Also, some of the 3D printing stuff seems a little too magical from my point of view. It's like, if it breaks, can I fix it? I don't know, maybe it's something like you're sort of brain dead with me, where I get more fun out of sort of figuring out the process of how things work as opposed to actually doing the end result sometimes. So that was one issue with 3D printing. So one of the things that kind of caught my eye, this was about a year ago, maybe 9 months ago, and I don't even know where I found out about this. This might have been on Twitter or some email list or something like that. But anyway, I saw this ad. It's like, a do-it-yourself CNC milling machine for $300. Like $300, that's crazy. I mean, if you know anything about CNC milling, it's one of these things, like if you try to order a CNC milling machine, it's like $5,000 or $2,000 or something. So this is crazy. It's like $300. This Shape Oko project, basically a one-man project. You kind of got this off the ground on Kickstarter. It's a Chicago area guy, so I mean, I live in Chicago, so I kind of like that. Super cheap. Figured if it wouldn't work, well, I was only out like a couple $100. Okay, so decided to. And also just what this is, by the way. CNC milling, if you have not done that, it's basically computer-controlled high-speed knives, if you want to think about it. Okay, so you're basically milling woods and plastics, maybe metals if you have the right equipment, but it's like high-speed, tons of noise, flying debris, and sort of thrilling danger, if you want to think about it that way. And I mean, I probably shouldn't tell my wife about this, but I looked at that and I was like, yes, this is for kids, right? And you're like because, it's like this very visceral thing. They have the 4-year-old come down there. And it's like, you better put on safety goggles, and I want you to stand like 6 feet away. And I have earplugs too, It was like this very exciting, exciting process going on there. So, perfect for kids. To do that. One other thing too about this, want to make some distinction here. Do-it-yourself does not necessarily mean industrial CNC machining. I mean, this is like a well-trodden area of manufacturing. I'm not buying like a $50,000 CNC machine and going to come make stuff here. I mean, this is basically like a $300 tool that literally has like a $15 Dremel tool hanging off of it from the hardware store. I mean, it's a total do-it-yourself thing. So, ordered this thing. Keep in mind, I have like no idea about CNC. I've never done this before. This is probably the recipe for disaster, actually, right? Okay, this kit, this massive kit comes. Never done anything with CNC. I'm purely a software guy, right? I mean, I spend all my time writing books and doing meta classes on everything and stuff. And it's like, okay, what could possibly go wrong with this? Like, pure software guy, high-speed rotating knives. No idea what he's doing. Okay, so seemed like kind of like a perfect project. Get the kids involved. So this kit shows up, and I thought I would just sort of show you the instructions for this. I mean, admittedly, this is a Python conference. You're like, it's not about CNC machines, but this is sort of what was involved in putting that together. There was sort of this instruction sheet where assembling wheels and different wheel assemblies and then different plates. And stepper motors, there's actually quite a few parts to this thing, like maybe 100 washers and different things kind of going together with motors and bolts and plates and rails and screws. I had to learn how to like thread basically rails with like a tapping device. I'd never done that. And so you sort of assemble all this stuff with the different pieces. It sort of comes together and, looks kind of like that. You sort of end up with a tool that looks like that. It's basically a couple of rails, sliding plates, some stepper motors. It can sort of move like in an XY direction and up and down. Get something like that. Sort of a perfect kind of, Wile E. Coyote sort of esque project to sort of work on there. One thing about this is it involved significantly fewer curse words than the stroller I had to assemble. How many of you had to assemble like a stroller or something? Oh God, it's like actually, since this is my opportunity, I would just like to say that Phil and Ted, you suck. Okay, your stroller sucks. Okay, so we bought this like high-end, this hipster stroller, and like no end of cussing on putting that thing together. Okay, and it cost more than the CNC machine. So yeah, lots of fun there. Now, to get started with something like this, you say, okay, well now what do you do? Basically, hello world on this. You essentially just strap a Sharpie to it. And then you make sure that you can start doing stuff. So they kind of have a hello world program that you load up, and then just sort of see if you can draw. And it's it's a little bit of fiddling around with that to get that to work. And then you sort of get to a point where it's like, gee, I actually need to cut something with this, like for real. This is sort of the leap of faith, right? It's like I'm a software guy. I don't know anything about cutting anything. What in the world am I going to do with that? So I decided that I would undergo kind of an obvious practical first job. I'm going to see whether you can. I'm going to crank the volume on this. This is a video of this.
Show everybody how to remove the gill using Python 3.
So my first job, I basically decided that I needed to remove the Python gill from a board. So you might be able to watch that import gill here. If you know anything about me, I'm fascinated with the global interpreter lock.
All right, everybody ready for this?
Now there's a whole bunch of things that are horribly wrong about what I'm doing here. It's like I'm cutting at too slow of a speed. It's too deep. It's actually starting to scare me a little bit, but. Okay, so this goes on for a little bit. That gives you an idea of what it looks like to do this. If you let it go the whole way, you end up with this. Yeah. People, I had this over in my booth. They're like, "What is that?" And I was like, "Oh, I removed the gill." And they would just like, they would turn around and just like not even say anything, just go the other way. Actually, we could set that there. Okay, so that was like a first job, and it's like kind of scary. I mean, I'll talk about some of the issues with this in a second, especially being a software guy that doesn't know anything about milling. So remove the gill. But then the fun thing about this is, the whole premise of this talk is, I want to make toys. So you sort of think about, what kind of things can I make with this thing? So you start thinking about things like, maybe I could like mill up a bunch of Lincoln logs or something. Okay, that was one project. It's kind of a stupid project. I probably spent like 3 times as much money doing that as just buying Lincoln logs. And then, then one day the kids, they come in and it's like, I want a wooden train or something. And then the other one's like, I want a wooden fire truck. And so, okay, how am I going to do that? So I don't know whether you can see that there. It's sort of a wooden train and fire truck kind of in the process of assembly there. And then you get these other challenges, it's like, can you make a ladder for my fire truck? Okay, so the kind of the fun thing about this as a parent is like the kid becomes like this challenge. It's like a challenge project for you, right? They'll come to you and say, I want this. And You sort of think about, can I make that? And every now and then they'll come to you with some ridiculous request, for some contraption. You say no, and then there's this whole meltdown of like, oh, Daddy, you suck. You can't make it. Okay, so you get ladder for fire truck. At one point they were like, I want wings, and you're like, detachable wing? What in the world is that for? Well, that's so you can have your wooden flying train. Okay, so I don't know whether you can. I don't know whether you can see that or not. The flying wood train there. And then it sort of turned out, sort of some point later, it's like, well, I want a flying wooden train with like a hidden pirate treasure chest section in it. Okay, basically you wanted the steam portion of the train to be this thing you could open up, and then you wanted to be able to put like Matchbox cars in there or something. So I'm thinking, it's like, okay, how in the world is that going to work? So you start building things like interlocking rings on dowels and stacking things together. It's sort of at this point where it's like, dude, I'm going to make you write a requirement doc. Yeah, this might be a good analogy for some of like client projects, right? It's like. You got to narrow down what the spec is on this thing, this pirate flying wooden train rocket ship sort of thing. And if you don't stop crying, I'm going to make you do it in DocBook XML. So, yeah, okay. So it's sort of a fun. You can sort of see this like, it's kind of fun to do this stuff. Some other things that you could do, for yourself. I mean, this is. You've probably seen this online. You could make yourself like a little miniature bike shed. This is the so-called red bike shed that I've been like tweeting about there. So it's kind of this fun, this fun thing. One random consequence of this, by the way, this is sort of a weird thing. This phrase has actually started to be uttered in the house like all the time. The kid is always like, "Daddy, can you make something?" It does not mean go down in the shop and make something. What it actually means is install something on the iPad. And like, I'm a little bit wondering about this. Like, they must think, I wonder, like, am I some super genius for like creating Angry Birds in like 4 minutes or something like that? They sort of, it's like, am I just conjuring up apps out of thin air on my iPad? Kind of a weird thing. So anyway, I actually want to talk a little bit about what's going on here. In the keynote they talked about, it's cool to make stuff and so forth. For me, I sort of admitted I didn't really know a whole lot about this. I don't know how many of you feel that way. Do you kind of? Actually, I'm sort of. How many people kind of look at some of the maker stuff with CNC and 3D printers, and they like, well, it's kind of cool, but I just don't know much about it. Okay, yeah, actually quite a few people. I was definitely in that camp. I just don't know much about it. So what do you need to know about it? Well, here's kind of the setup on this CNC milling machine. It's basically 3 stepper motors hooked up to an Arduino controller, which is plugged into basically a laptop via USB. The actual milling part of this, actually my cursor doesn't show up there, is just literally like a $13 rotary tool from the Ace Hardware. It's like if you burn it out, you just go get another one. It's literally that cheap. This is total do-it-yourself kind of stuff. The big red button on there, by the way, is a panic button. If anything goes wrong, you stomp on it. We'll talk about that. And the software for this is super easy too. I mean, it's so cool. It's basically just Pi serial. You just open up a serial port, and then you just send it commands. I mean, I'm almost embarrassed to show this at a Python conference because that's literally all it is. Just send a command, get a response back. And then the way to view this thing is it's basically a glorified plotter. It's computer graphics. It's like vector graphics, okay? So if you want to draw something, you have coordinates and so forth. These are sort of the commands that I'm showing over here on the left. Those are sort of G-code commands. It's kind of like turtle graphics, kind of almost. It's you're just saying, okay, go, like the G1 Z10 means like go up 10 millimeters, and then the G00 would be go to the coordinates, and then basically the only difference between this and like computer graphics is the Z coordinate. Like you can go up and down. And so forth. Probably the big difference between this and computer graphics, though, is the whirling knives component of it, right? Okay, so you're in the real world. You're basically plotting with with an end mill bit that's maybe spinning at 20,000, 30,000 RPM, high speed, there's a ton of physics associated with that as far as things like, what are the cutting angles of it? What is the shape of the bit? How many like flutes does it have? What are the angles of the flutes? What direction is it traveling? So you're definitely kind of in the real world there. Because you're in the real world, there's physics. You can't violate like conservation of momentum or things like that. So there's things like no instantaneous motion. You have to do things like acceleration and deceleration towards points. There's inherent like hardware limitations. Like if you drive, like one example is if you go too fast in a certain direction, the machine actually might start like vibrating due to just the way that the linkage between components works. There's things like material properties that we'll get into. It actually turns out that you would think that this is like, okay, it's just like a plotter. How interesting could it be? It turns out it gets really interesting if you get into all this, like the different kinds of bits, the physics of it. There's certain geometry restrictions of what you can do with this thing. Like you can't do like undercuts. That's what's in the middle there. You can't take this cutter and take it precisely into like a sharp angle because it's there's like a certain width to it, so you can't cut into vertices. There's also sort of real-world hardware errors in this. The fact that you're using like a $14 or $13 little rotary tool, you'll find that like the end of the cutting bit might actually sit there and wobble slightly. This is something that you might have to play with or adjust. So you'll end up with like wobbling in the tool, where if you tell this thing, I want to cut a path of a certain width, it doesn't come out right. So you need to sit there, you need to measure things, you need to kind of tweak bolts and stuff. It's a cool project if you like this sort of thing, you're just like tweaking stuff and so forth. The material science side of it is also interesting. I mean, if you think about like all the variations of something like wood, you could spend hundreds of hours experimenting with that. Like, what's the difference between oak and maple and aspen and balsa wood and like, grains of the wood, like the directions of cutting. There's like all sorts of stuff there. You get into plastics are kind of interesting, acrylics, wax. You can mill things like aluminum if you have maybe the right cutting bits and the like stronger motors and things. So there's like tons and tons of different properties there. And it actually does become kind of a science project. You get into things like, well, how fast can you drive it through material? Like what rotational speed do you need to do it at? What cut depth do you do it at? Actually involves like just tons and tons and tons of experimentation, which makes it actually quite fun in a certain way. It's almost like you have to gain experience on your own that you can't really just read about in a book. I mean, maybe you can get it in a book, but I don't know. It's sort of like you have to kind of try stuff. Like one of the things that I'm showing over here is on the bottom right is an attempt to mill acrylic, which has just been like an absolute disaster for me. I mean, the problem with acrylic is that it tends to melt. And so like if the speed of the bit is too high or you're pushing it too slow or you're not going at the right speed, it basically melts the material and then the whole tool like sort of goes off course or it gets wedged or jams or something like that. So a lot of little experiment stuff. One of the things that I'll sort of mention, there's probably a whole reason why there's a really expensive CAM and CAD/CAM software out there. I mean, this is basically all this tooling stuff would sort of come under this sort of CAM heading. Just so you know, there's a Python CAM tool. There's free Python, it's PyCam. I've never used it. I'll talk about why in a second, but I don't know, never tried it. 15 minutes? Okay. So it turns out that, if you don't want to do that, you can actually do sort of do-it-yourself CAM by just writing short scripts. You can actually describe a part with some coordinates there. Just saying there's a part. You can just literally send it out the serial port in G-code, and then all of a sudden you have your Python code controlling whirling knives, and it's like, oh, this is awesome, my script controlling whirling knives. One thing that's cool about this is that any programming error has physical form. You'll all sorts of interesting things there. There are actually real dangers, like you might drill through the table, you might jam the tool, you might actually shatter the bit on the drill. You can actually get into things like harmonic vibrations. This is actually a really interesting thing when it happens. Like you'll be cutting through a material and then it'll start shaking and you'll hit like a resonant frequency and kind of the setup or something, and then it will really start shaking, and then you're like going to pound on the panic button because you're too scared. somebody might, one thing that somebody, I'll point out, maybe you should be using test-driven development. All I'm going to say about that is that sometimes it actually really is cool to see it drill through the table. Okay, so yeah, it's like, it is kind of exciting, it's like, why would I want to prevent it? I don't know. Okay, so I've been kind of thinking about this. One of the things I've been sort of messing around with is things like, could I use IPython notebook to do like tool plan calculations or something like that? Just as a fun, partly because is there anything that IPython notebook can't do? So why not, CNC milling or something like that? So one of the things I've been messing around with is this idea of making marble track. I don't know, I got some of this stuff here. It's like, could I plot a math function just into marble track? It's sort of a stupid project. It's kind of like matplotlib gone horribly wrong or something like that. And so kind of the idea is, you take this marble track, there's like maybe a cross section, and then there's like a view on top, and then what you're going to do is form a track where you lay out that cross section along like normal vectors or something like that. And it's like, okay. And it turns out that you can do stuff like that with this IPython notebook. I'm going to see if I can do this real quick, but actually I think I already had it up here. Okay, do that. So you can do things like write like a little marble track planner, where you have like parameters for the the cutting of things, functions. You can do like little plots, sort of showing you what the tool, like this is like the basic path of the tool, and then you can start building this up by doing. I'm not going to go through the code so much. I mean, calculating derivatives and normal vectors and things like that. But you can sort of plan it out and say, okay, well there's like the there's like the region that's going to be cut out of this thing. And really the whole idea of this is just to avoid drilling through the table or through the to get like a visualization of what is going to happen. And then you can do things like start to calculate, the paths of tools and chaining things together, and you might end up with something, something like that. Basically, the different colors here are like one single path of this drill bit, where it would basically go across the piece, and then it would do a U-turn, and then come back across the piece, and then do a U-turn. And the way you carve this thing out is you sort of go back and forth along the contour, and then the change in color is basically the presence of like a rail, like a raised piece of the piece. So I'm going to jump over that, and then I'm going to carve out the middle, and so forth. So it's kind of a sort of a fun application of maybe IPython notebook to sort of you could play around with these paths. You can change the function to something else. Like let's just change parameters and do a different path here. Okay, so you can kind of go through this and say, okay, well, there's like a more curvy path, and then you can actually discover like errors in your code. Like this is actually starting to look kind of weird. If you look at that, it's like, what in the world is going on there? That's basically you're getting like a curvature problem with these. Like if you're laying out rail, if it has too tight of a turn, you end up with these like the cross sections like intersect with each other, and you'll end up getting all sorts of weird cutting effects if you try to do that. So it's actually cool that you can do this stuff, in Python. This is actually what it looks like to actually mill like one of these carving things out. You start with a board, and then it starts basically plotting a math function. Again, this is like probably the coolest, loudest matplotlib type thing ever here. It's like 100 decibel, matplotlib. You carve out a section, and then it just sort of gradually works its way through the piece, and you sort of see your track sort of taking form there, and then you end up with a piece. Kind of looks like that. Okay, so get some piece out of that. You often have to sort of sand these things down a little bit afterwards because they've got maybe rough edges or little burrs or things like that. There are some challenges with this. Actually, exceptions are fairly common. Actually, what I mean by exceptions is that it actually takes a fair amount of time to mill something like that, by the way. It might take 45 minutes, maybe even an hour to kind of crank through something like that. You might actually discover part way that you've done something wrong. I mean, it could be a programming error. It could be actually a tool error where maybe it sent a command and it didn't actually activate like a stepper motor or something, and the whole thing is like offset, and you're like, oh crap. So there is like this panic button that you can hit. And then it often leads to like an interesting complexity, like, how do you stop these jobs? Can you save the workpiece in some way, like after you've already started it? That's kind of an interesting software project that I have not figured out. It actually really sucks. Like, to do this, what you often have to do is actually go in and modify the source code to comment out part of the job and then resume from the non-commented out part there. So you have that. User testing is kind of fun. You throw it at the kids and they sort of see what happens. And you have integration testing, multiple parts with wood blocks and things like that. You can get into some more interesting variations. I've been kind of experimenting with marble track that has like z-axis variation. So it's not only is it like a wave, but it will like ripple on top. It's sort of some interesting challenges there. There's also some future direction stuff with some of the CNC milling. Like, I'm kind of interested in this idea of things like plastic resin casting. The idea here is you would make a part in like a wax and then make molds and then do plastic casting in it. This would almost take you into the area of like 3D printing, like doing stuff with plastic, but through a different route. Another possibility, it sounds intriguing, is you can do CNC milled printed circuit boards. I hadn't really thought about that, but the idea is you take like take a circuit, like just a sheet of like, this copper covered circuit board, put it in a CNC machine, and then you carve out all the traces on it. That might be kind of cool later on, so do stuff like that. So kind of getting to the end of this, you might say, okay, is there any point in any of this? Okay, this is just stupid. It's like CNC is this thing. It's a long solved problem. People have been doing this for since the 50s, right? It's like, why even bother with this kind of stuff? And I think the only answer I would sort of put on there is that I've actually found this to be just as fun as the first computer I ever had. It's awesome. I mean, it's like you get in there and it's like whirling knives and you're playing with it. It's actually simple. It's accessible. I mean, I could see like, I could definitely see like a kid maybe a little older than 4, obviously, doing stuff with this, like turtle graphics and stuff, $300. And if you think about the first computer, it's like in 1978, programming was a solved problem too. And submitting JCL scripts, that was a lot of fun, and real computers there. So I don't know whether there's any much point to it, but I think kind of the big picture is I just think it's supposed to be fun. If you think about why you're using Python or why you're here at this conference, I would actually hope that it's because you think Python is fun. I mean, I'm hoping nobody is here saying, "Oh God, I got to go to the Python conference." A bunch of losers. It's going to be about XML every session. Like that. Okay, so there's this thing. It's like if it's not fun, then why bother with it? And then even maybe even a kind of a bigger point. Actually, my wife sent me this quote actually like 2 days ago. I thought, oh yeah, that's kind of perfect. I think, for me, I mean, getting into my 40s and so forth, when you think about these things, like how do you make computers fun for the long haul? I actually read about these things online every now and then. You hear about like, people burning out of computers. It's just like, oh God, it sucks. I can't take it anymore, and all this stuff. I think, for me, I think one way to keep it fresh is just to try new stuff, even if it's just ridiculous or stupid or no practical point. That's like some of this like CNC stuff. It sort of serves that role. I mean, I sort of really like that. So some final comments on this. I would just say this is something you can do. I mean, if you've actually thought about this kind of maker stuff with, like robots or CNC mills or stuff like that, it's really accessible. I mean, you can start writing Python scripts. You can do serial ports. It's a lot of fun. This kit that I got in, just to put I'm not affiliated with that guy at all. I mean, I've met him, but it's. The Shape Oko project, that's where I got the milling stuff. Some of the CNC stuff, if you really want to know more, there's this excellent sort of guerrilla guide to CNC. They'll talk about all the details and so forth. And so that's basically it on the talk. I mean, admittedly, it's just sort of a fun, goofy topic. So I think I have like some time for questions if anybody wants to.
if you'd like to come up to the microphone to ask questions, that'd be great. We've got about 10 minutes.
I saw on your slide you mentioned TDD, kind of like jokingly.
Yeah.
But like, is there a way to like, I don't know, just run a simulation of it while also simulating the response of the material? And, you know, kind of have a in silicon.
Man, that is a tough question. I mean, you can definitely run, like I could definitely run like a simulation of the tool path and like see that in 3D.
It's like simulate something
But
going wrong with the material.
simulating the material. I mean, obviously the answer is yes, that you probably could simulate the material, but whether that's actually accessible to me as just like a rogue hacker or something, I don't know. Because there's like so many like physical parameters of the material, like how hard is it, you know, things like that. I don't know. I mean, I might actually have to go get like a material science degree at the college or something to. Yeah, just experiment. I mean, actually, honestly, a lot of it has just been coming from experimentation. You run it, and you're like, gee, it looks like the tool is about to explode. Maybe I should like back off a little bit, like decrease the feed rate or lower the, like, you know, not cut so deep or something like that. So.
I would have thought that sawdust and computers don't mix. How do you deal with that?
Well, you know, I'm not sure about that. Well, first of all, I don't know whether they mix. I will say that this laptop, which is the same one that I've been doing the milling on, has gone through 2 hard drives in the last like 6 months. And and I don't know, you know, the thing that's a little weird is I've actually, you won't believe this, I've actually never had a hard drive crash in a personal computer for like 25 years until this, okay? So, you know, maybe I got exceedingly lucky, but yeah, like 2 in 6 months, I don't know. I don't know, you know, I don't know whether having a machine filled with sawdust would cause a hard drive crash. I don't know whether there's like vibrations. It could be a vibrational thing, you know, like, you know, this thing is on a table with a CNC machine, and maybe, you know, maybe the hard drive isn't so, you know, sensitive to like big vibrations, but maybe like if there's a constant stream of like very rapid like vibrations on the table or something, it's causing that. I don't know. It has Apple Care on it, right? So I just take it in and. But yeah.
So what's next?
I don't know. What's next on this? I mean, actually, I'm kind of interested in sort of the resin molding stuff. So.
I'm wondering if there's an equivalent of a printer test page for a CNC mill, like something that you could just, like a very standard track, but the result of which would tell you a lot about the material that you're working with. You know,
actually, there's a guy who's been working on that. I wouldn't be able to pull it up offhand, but yeah, actually, somebody for this machine basically made like a calibration pattern. It's kind of hard to describe. It has like different things like rings and different like lengths and thicknesses and so forth. The idea is that you would mill the calibration pattern and then basically get out like calipers or something and then try to do like precise measurements on it to determine things like, you know, is it cutting round in a round way? What are the tolerances on that? It's actually really tricky to get some of that stuff down. I'm constantly like finding myself fiddling with like even things like bolts and stuff to kind of, you know, tighten things or loosen things and so forth.
Well, you cost me $300. Well, it occurs to me you might try putting little strain gauges on the bracket that holds the tool, so that you can monitor, and you can monitor that with the Arduino and try to get an idea of if you're pushing too hard. So
that might be interesting. Yeah,
that might be a way to approach that. But I do want to thank you for telling me what to do with my Raspberry Pi.
Oh, okay. Yeah, actually, on the subject of retrofitting stuff, that's actually one cool thing about like a project like the do-it-yourself project. It becomes this almost infinitely customizable thing where it's like I actually customized mine to be longer in one of the axes. And you can kind of tweak it. It's like actually probably the danger is that the tool costs like $300, but then you can go off and spend like $1,000 on end mills or something. You know, that's definitely don't tell your wife about that. You know, I spent $1,000 on drill bits or something. Okay.
You showed that picture of the clear plastic and how you had the problems with the melting. Do you know whether that's a solved problem?
Is it a solved? Oh, what?
Is there a solution to that problem?
Oh, it's milling acrylic. People have done it. but there's basically like a window that you need to be operating in as far as like what the feed rate is and what the spindle speed is, and maybe even using the right kind of cutting bit on it. I just haven't gotten into that window of figuring that out yet. So.
I was curious if you thought about integrating CCD cameras to do calibration while the thing was going as a positive feedback.
Yeah,
source.
CCD cameras. Yeah, I don't know.
Some sort of
Yeah,
visualization.
maybe.
And next year I want to see autonomous.
Autonomous.
Self-replicating
Yeah.
robots.
With meta classes.
With what?
Exactly.
With meta classes? Yeah. I mean, actually, one of the things somebody asked about future directions. I'm actually sort of more interested in what I would call like sort of algorithmic milling, as opposed to doing like CAD CAM stuff. Like, could I code some algorithm like, oh, I'm going to mill out like a fractal or some weird thing, and then provide it in there and see what happens. One thing I've been thinking that might be cool would be to take topographic maps, like that, and see, could I mill out like a wood representation of a mountain range or something in slices or something? Maybe just completely automated with a Python script, where it's like, you give me a topographic map, I'm gonna have like a Python program that analyzes that and just lays out a tool path and then does it. I'm not ready for that yet, but sort of think it might be kind of cool to do stuff like that.
So continuing on your theme, have you thought about making it dual core and having two routers that would route it at the same time, and the problems that you would have to, finish a job with two routers, kind of
Two routers on the same
Yeah.
table? I'm not even going to go there. It's already scary enough when it breaks there. So. Yeah, actually, I do like to say, I would like to just say that, if you do have like an error, like I think I mentioned the error thing back here, like that was probably the gill there. Probably. I mean, I'm not certain, but yeah, probably. So.
Thank you, Dave.
Okay, thanks.